Hello dear students. Let's understand Finkelstein reaction in this particular video. This again Finkelstein reaction again is also an interconversion method. Finkelstein reaction is also an interconversion method wherein we are trying to convert the alkyl chlorides or the alkyl bromides into alkyl iodides. I repeat, what are we going to do in the Finkelstein reaction, children? We are going to convert alkyl chlorides or the alkyl bromides into their respective alkyl iodides. Meaning, we are going to bring about interconversion of the alkyl chlorides or the alkyl bromides into alkyl iodides. And what is the method to do that? Very simple. Again, we are going to bring about the process of heating of the alkyl chlorides or the alkyl bromides. And this heating is carried out with one more component, which is sodium iodide. Can I use sodium iodide directly? No, there is a condition to use it. We need to use sodium iodide in dry acetone. So, what are we going to do in the Finkelstein reaction, children? I repeat once again. We are going to do the interconversion of the alkyl chlorides or the alkyl bromides into the respective alkyl iodides by heating the alkyl chlorides or the alkyl bromides with sodium iodide in dry acetone. Now you may be wondering, don't we have any better job to do? Why are we all the time trying to do an interconversion of the things? There is a reason for it. Now let's understand why we are bringing about the Finkelstein reaction in the first place. Finkelstein reaction in the real life is useful because the alkyl iodides, whatever we are going to prepare from the Finkelstein reaction, children, is used in various industries for various purposes. I have listed a few for you here. The first usage being they act as active pharmaceutical intermediates, which we call it as APIs. Active pharmaceutical intermediates, which we call it as APIs. Apart from that, we also use the alkyl iodides in the manufacturing of dyes in large quantity, and obviously the alkyl iodides find its use in the agrochemical industries for obtaining the herbicides, fungicides, etc. And it is also used in many organic reactions as a laboratory reagent and also for chemical research. Now that you got a brief idea why we are bringing about the Finkelstein reaction and why is it or how is it useful in the real life. Now, with that being said, let's understand what is the reason for us to use the dry acetone in the reaction. What is the reason for us to use dry acetone in the reaction? Acetone, children, by nature is a polar aprotic solvent. Very, very important. I repeat, acetone is a polar aprotic solvent. That means it acts as a good solvent for dissolving the sodium iodide. Sodium iodide is our reactant, meaning to say this acetone acts as a very good solvent for the reactant sodium iodide but acts as a poor solvent. It does not dissolve the sodium chloride or the sodium bromide which is obtained as a product. Therefore, it is easy for them to precipitate out once the reaction commences. And if the byproducts, one of the byproduct in the reaction is not available, it is precipitating out. That means it brings a pressure on the equilibrium as per the Le-Chatelier's principle, and therefore the equilibrium shifts to right. That means forward reaction is favored. Therefore, we'll have more production of alkyl iodide. Now, the next question is, why should we have dry condition for the acetone? We have mentioned dry acetone. Can you see this dry there here? Why are we carrying out the reaction with dry acetone? Acetone, we understood, is a polar aprotic solvent. Why dry? What will happen if there is water in this? Very simple, children. If water is present, it will act as a good solvent for dissolving sodium chloride and sodium bromide, which is not required for us in this particular reaction. And if water is present, the reaction goes in sideways, like it does not give us the required product in good quality and in good quantity. Therefore, usage of acetone is important and usage of dry acetone is also equally important. So with that being said, now let's understand about writing of the general reaction equation, and let's take up the few examples for Finkelstein reaction. Now, how do we write the general reaction for Finkelstein? RCl is treated with sodium iodide, NaIn, and what's the condition? The reaction has to be brought about in presence of dry acetone. Why we are using dry acetone? You have already learnt the reason, because dry acetone acts as a good solvent for dissolving the reactant sodium iodide. So when we bring about this reaction, now what happens? The iodide part will displace the chlorine from the alkyl group, and this is a simple nucleophilic substitution reaction. This is a simple nucleophilic substitution reaction. Again, this reaction will occur as per SN2 reaction mechanism. This reaction will occur as per SN2 reaction mechanism. The product obtained will be having inversion of configuration. The product obtained will have inversion of configuration. So these are the extra points I want you to remember. The reaction is a simple nucleophilic substitution reaction, and the mechanism is SN2 reaction mechanism. As a result, the product obtained will have inversion of configuration. Let me just clear the board before we proceed writing with the equation. Okay, now what's the product going to be? See, this R will now combine with the I, and we obtain the respective alkyl iodide along with this Na will combine with Cl, forming NaCl. Thus obtained NaCl will precipitate out. Therefore, the equilibrium will shift to right, favoring us the formation of the alkyl iodides. Let's write the name, all the general names. So, what's the name of this reactant going to be? It is chloroalkane. That's the general II PUC name. We can also call it as alkyl chloride. It's a trivial nomenclature. Alkyl chloride, and the product obtained will be iodoalkane, or the trivial nomenclature general name will be alkyl iodide. Alkyl iodide. Now, for understanding with a suitable example, let us replace R with a methyl group in the first case. So now let's replace this R with the methyl group and write the reaction equation. So now CH3Cl reacts with sodium iodide in presence of dry acetone. Obviously, we are bringing out this reaction with the process of heating, and therefore it undergoes nucleophilic substitution by SN2 mechanism. And what happens now? Sodium chloride is obtained, and this iodide will take a linkage with the methyl group. So we have CH3I along with NaCl. Now let's write the name of all of this reactants and products, children. The name of this compound going to be chloromethane. Chloromethane. That's our II PUC name. Otherwise, I can also call it as alkyl chloride. I can also call it as alkyl chloride. That's a trivial nomenclature. And what's the name of the product we are going to get? Iodomethane. Iodomethane. Or it's also called methyl iodide. Methyl iodide. Now let's take up example 2 by replacing R with C2H5. Let's replace R with C2H5. C2H5 is ethyl group. So what's the equation going to be? In this reaction equation, let's replace R with C2H5. C2H5Cl plus NaI. What's the reaction condition, children? By this time you should be already knowing. We are using dry acetone. You already know why we are using dry acetone. And we are subjecting it to heating. Now what happens? They undergo nucleophilic substitution, wherein the chloride is substituted by the iodide. The chloride is substituted by the iodide. Now we obtain C2H5I as the major product along with sodium chloride. So now let's write the name of this reactants and the products. This is chloroethane. Chloroethane, or otherwise called ethyl chloride. Ethyl chloride. And here the product is iodo. Product is iodoethane. That's the II PUC name, or the trivial nomenclature will be ethyl iodide. Ethyl iodide. Similarly, here I should have written as methyl chloride. Methyl chloride. Now, this is with respect to halogen being the chlorine. Now let's take up what will happen or how to write the reaction if instead of alkyl chloride, if it is alkyl bromide. So the general reaction equation for that case would be RBr plus sodium iodide, and the condition is having dry acetone and we are subjecting it to the process of heating. Now what happens? The Br is substituted by the I, and Na will settle down with Br. Okay, so the product will be Ri along with NaBr. So thus NaBr bond will precipitate out, therefore equilibrium will shift to right, favoring the formation of more and more quantity of the alkyl iodide. So what's the name going to be? This is bromoalkane. Bromoalkane, otherwise called alkyl bromide. Otherwise called alkyl bromide, is treated with sodium iodide in dry acetone. Treatment here is process of heating, and the product obtained is iodoalkane. Iodoalkane, that's the general II PUC name. Alkyl iodide is the trivial general name for this product. Now let's replace R with CH3 in the first case. So what's the equation going to be? Let's replace R with CH3 and write the equation, children. You also try writing the equation along with me, or if you are not writing, at least start saying the equation orally. Therefore, it becomes a good practice for you. Okay, we are replacing R with CH3. The equation will be CH3Br along with NaI, sodium iodide, in presence of dry acetone. Upon heating, now you know what happens. What happens now? Iodine displaces the bromide from the alkyl group and settles down as NaBr, and we obtain CH3I. CH3I and NaBr. Now try giving me the names. This is bromomethane. Bromomethane, otherwise also called methyl bromide. Otherwise also called methyl bromide, treated with sodium iodide in dry acetone, is giving us what's the name of the product, children? This is iodomethane. Iodomethane, or iodomethane is the II PUC name. Methyl iodide. Methyl iodide is a trivial nomenclature name. Now let's take up the second example for this also. Let's replace R with C2H5. Now can you also parallelly write the equation along with me, the correct equation? So when you start doing it, it becomes a very good practice for you, and you will not make any mistake in the exam while writing the equation. Okay, so now let's start. C2H5Br, which is our bromoethane, is treated with sodium iodide. Now what happens during this process? Nucleophilic substitution reaction occurs by SN2 reaction mechanism, wherein the iodide of the sodium iodide displaces the bromide from the ethyl group. So what's the necessary condition you should remember to write, children? We have to do it in presence of dry acetone. Process is heating. So what's the product we are going to get? C2H5I along with NaBr. Now let's write the name of this important reactant and the product. What's the name of this compound going to be? It is bromoethane. Bromoethane, otherwise called ethyl bromide. Ethyl bromide. And the product obtained is iodoethane. Product obtained is iodoethane or ethyl iodide. If you write reaction equation like this, you will get complete mark. Now, is it mandatory that you should be writing all of these 6 equations? No, I am writing it so many times so that the concept becomes very clear to you. It becomes very easy for you to write the equation. So therefore, any one example you can take it and write it in the exam. Now you learned how to write the reaction equation, the general reaction equations by taking the chloroalkanes or alkyl chlorides or the alkyl bromides and converting them into respective alkyl iodides. And each case we have learned it with 2 examples. Now let me just show you how exactly the question on the Finkelstein reaction is asked in the examination. These are some of the ways that the examiners might ask question in the exam for you. What is Finkelstein reaction? Just 1 mark, direct question. So answer should be, it's a halogen exchange reaction in which the alkyl chloride or the alkyl bromide is converted into alkyl iodide by heating with sodium iodide in dry acetone. If you write this completely, this statement I have shown you as per matching what is called as the scheme of valuation. If you write all of these points in this way, you will get this complete 1 mark. Now, one more way for 1 mark that the examiners can ask you the question on Finkelstein reaction is, children, write the equation for Finkelstein reaction. So they are wanting you to write the equation, which is a general equation, and this is how you can write this. RCl, ROR, or RBR. You know what is RCl by this time, which is alkyl chloride, or RBR is alkyl bromide, is treated with sodium iodide in dry acetone, gives us iodoalkane or alkyl iodides with NaCl or NaBr. You know when NaCl comes. When we take RCl, we get NaCl. When we are taking RBr, that is alkyl bromide, you will get sodium bromide as the byproduct. Now one more type of question that can be asked for 2 mark. Why dry acetone is used in Finkelstein reaction? This we discussed in the beginning when we started with understanding of Finkelstein reaction. Because this dry acetone being a polar aprotic solvent, it will dissolve the reactant NaI but does not dissolve the products NaCl or NaBr formed. As a result, the NaCl or the NaBr formed precipitates and it brings pressure on the equilibrium to shift it to the forward direction as per the Le-Chatelier's principle. When this happens, this will result in the increased yield of the alkyl iodides. So these are just few 3 exam questions that I have taken. I've already listed all the different type of questions that can be asked on the concept of Finkelstein reaction. I have made a PDF of that and I have given the link below. You please download and you can use it. It is absolutely free. My only concern is I want you to go through that, get exposed to the type of questions, how the questions on the Finkelstein reaction is been asked in the exam, and I want you to score complete marks on that. I hope you understood Finkelstein reaction in the best way and in the most easiest way, got exposed how exactly the reaction occurs and gets to completion, and what are the reasons behind it, and where do we use this Finkelstein reaction. I want you to keep practicing, children. Keep improving your scores. All the best. And of course, I have one request to make. Remember to subscribe to the channel, like and share. It motivates me to give you more. All the best.